The next interesting and very important data structure is called a stack, right? So this is a very important data structure. This is a very interesting data structure used extensively in computer science in various areas. Okay, I'll motivate you with some examples. But before we go there, what is a stack? You can think of a stack of books. You might have heard the term a stack of books, right? You might have heard of the term the stack of books. Basically what it means is that, okay, let's assume I have a book here, right? On top of which I have placed another book, right? On top of which I have placed another book, right? On top of which I have placed another book. So if you think about this, this is, let's say, book 1. Let's say this is book 2, this is book 3, book 4. You've basically stack piled them, right? You've basically piled one book on top of the other, right? This is where you might have heard of the term a stack of books, right? So if you think about it, if I want to remove, let's say, if I want to remove anything from here, from a stack, okay, instead of this complex 3D diagram, let me write it as a 2D diagram, right? So imagine I have these books, okay, let's assume I have these 5 books. Okay, let's say this is book 1, this is book 2, book 3, book 4, and book 5. Okay, one is on top of the other, and this is on ground. Let's say this is ground. Ground is often represented by this, especially in physics, right? This is ground. I have book 1, on top of which I have book 2, on top of which 3, 4, and 5. Now, this is called stack of books. And typically, if you think about it, when you want to remove a book, from the stack, right, what do? You first have to remove the 5th book, right, for you to be able to access the 4th book, and then remove the 4th book to be able to access the 3rd book, and so on and so forth. Similarly, when you want to add a new book to the stack, what do? You can't, it's not trivial to add between 2 and 3 without breaking, or without making this whole thing fall apart, right? So typically, if you want to do it systematically, if you want to add something to this pile or stack of things, you typically add it to the top, right? You don't add it in between, you add it to the top. Imagine a pile of books or a stack of books at your home, or in your or at your study, right? So whenever we want to remove from a stack, we remove from the top, and whenever we want to add something, we also add it to the top of the stack. This is a very, very simple way of understanding what a stack is intuitively. Of course, we'll go into the computer science specifics of the data structure and understand them in lots of details in the next few videos. But if you think intuitively, right? Because we've seen a pile or a stack of books many, many times, right? So the easiest way to remember is whatever goes in last, right? For example, here I placed the 6th book last, right? So what is the last book that I placed? The last book I placed on the stack or pile is 6. But when I want to remove books, right, the last book that has been placed is 6. What is the first book? What is the first book that gets removed if I want to remove? It is also 6, right? So this is often referred to as a last in, first out data structure, right? LIFO. L means, so this is nothing but last in, first out. Okay, last in, first out. What does it mean? The last one which is put in, is the first one which will be taken out, right? That's why it's called the last in. Whichever item went in the last is the first item to come out. That's why it's called a LIFO, or last in, first out data structure, right? So the easiest way to intuitively always think of stack is is basically a stack or a pile of books, right? One placed on top of the other. That's the easiest way for you to imagine and think about it intuitively, right? Okay, having said this, now let's go and understand. Okay, so we have understood intuitively what a stack means. Why is it called a LIFO data structure? But why is it useful? Why the heck are we learning it? Why are we even learning it? Where is it useful? We'll see a lot of examples in the later parts of this chapter after we learn what is a stack. Okay, first we learn what is a stack. We learn what are the operations on a stack, how is data organized in a stack, etc. So that we'll be able to go into details on where all where all a stack is used and how a stack is used. We'll certainly cover many aspects of this in the later parts, but you'll not be able to understand where a stack is used and how a stack is used without understanding what is a stack, right? But before we get started on what is a stack, stack has tons of applications. Let me give you some examples, right? So one is called expression evaluation. One example is called expression evaluation. So let me explain you what that means. Expression evaluation basically means, imagine if I give a mathematical expression in your programming languages, right? In C, C++, Java, in any programming language. Let's say I give an expression like this: 23 plus 2 multiplied by 6 divided by 4 minus 2. Let's say you might say x equals to this. Now, if you notice, this is a mathematical expression. We need to evaluate this whole mathematical expression and find what is the result of this and assign that resultant value to x. Every programming language has to do this, right? This whole expression needs to be evaluated and the resultant needs to be put here. And for that, there are some precedences. For example, multiplication and division have a higher precedence than plus or minus, right? In any mathematical or algebraic expressions like these, because of the simple rules of arithmetic, right? So we have your star and division having a higher precedence than your plus and minus. Some of you may have learned something called as BODMAS, right? As kids in school, as a way to remember the preferences, where you have brackets which have higher precedence than division, multiplication, which have higher precedence than addition and subtraction. O stands for off, right? So you know this BODMAS rule where you have precedences of operations. Now, how do I evaluate this expression and assign the value to x? We'll see expression evaluation in lots of detail later in this chapter. But for this, we typically use, most programming languages use stacks to achieve this. Right? This is one very interesting application. The other interesting application is something called as a parenthesis check. Okay, what I'm giving you are very simple examples. There are many advanced applications of stacks in computer science, right? So there is another thing called as parenthesis check. What does parenthesis check do? Imagine if I have a complex expression like this: 21 plus 2 plus 3 by 2 plus 4 by 6 minus 2 plus 3 by 2, right? So now, now I'm confused myself thoroughly. So if you have an expression like this, right, which has a lot of parentheses, these are called parentheses or brackets, right? So these are called parentheses. This is an open parenthesis. This is a closed parenthesis. When you have a complex expression like this with many open parentheses and closed parentheses here, right? How do you check that this expression is valid? How do you check that this expression is valid and there are no errors in the parentheses? Right here, if you see, okay, this one, where is it closed? So this one, where is it closed? So this one is closed here. 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 So this one is actually closed here. And the first one is closed here. Right? So this is a valid expression because the parentheses are matching. For every open parenthesis, there is a closing parenthesis that is matching it. Right? So to check whether your expression that you're given, especially the parentheses part of an expression, is it valid or not? How do you check that? There are many ways of checking it. One way is to use a stack. One way of checking whether your parentheses are working properly or not, one very popular way actually, a very simple and popular way, is to use a stack. Similarly, suppose if you're writing a recursive function, imagine you're writing a recursive function. Right? We've seen lots of recursive functions anyone who writes programming languages, for example, if you want to compute a factorial, right? Or to compute a Fibonacci series, a lot of people use these as simple examples for you when you're learning programming language to teach how recursion works. Of course, there are a lot of sorting algorithms which are recursive. There is merge sort, which is recursive. There is quick sort, which is recursive, right? So recursion is something that we often encounter. But how do recursive functions work internally, right? How does your compiler how does your compiler, and how does at runtime, when you're programming at execution time, how is recursion made possible in the first place? Without stacks, you can't have, without a stack, it's very, very hard to have recursive functions, right? So most programming languages internally use a stack to make recursion happen. So that is called a call stack. So such a stack is called a function call stack, or in short, it is referred to as a call stack, right? We'll discuss about a call stack later in this chapter and how a call stack enables recursion to be possible in the first place in most modern programming languages, right? So very, 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 very useful. So a stack is used in multiple places. Expression evaluation, every programming language needs an expression evaluator. Parenthesis check, very logical thing. Recursion, because without recursion, you can write factorials, Fibonacci's, merge sort, quicksort without recursion, but recursion makes it easier for us to tackle, to understand, and to write crisp and clean code, easy to understand code. And all of recursion in most programming languages is enabled because of a call stack, right? So there are tons of applications of this simple LIFO data structure. We'll go through each of them, but we'll be only able to appreciate where and how a stack is used after we learn what is a stack, what are operations on a stack, and other details about a stack. So here we've just given you why we have to learn a stack, but after we learn what is a stack, you'll be able to see where and how. For example, how does expression evaluation happen using a stack? How does parenthesis check happen using a stack? How does recursion happen because of a stack? We learn all of this after we learn what is a stack in this chapter.